Modify a value in heap. How can you modify the value of a node in a heap? So whenever you want to modify, the only thing you have to keep in mind is that after modifying the value of that node, it should still be following the heap property. So how can you make sure that heap property is followed? This is what we are going to discuss in this lecture. So let us say you want to modify the value of this particular node in this heap. So how do you modify this value? Initially, you want to locate this node and then you can directly make the change. You can modify the value. But after modifying the value, this is when you have to start the algorithm in order to make sure that heap property is maintained. So there are two cases. Both these cases has to be handled separately. First case is that you increase the value. That is, whatever was previously present, you made the value larger than what was previously present. And the second case is that you decreased the value. So whatever was the value that was present, you decreased it. So it is a smaller number now. These two cases, they have to be dealt separately because they have different procedures to be followed. So we are considering that this is a max heap. So considering a max heap, we are going to do whatever we are doing. If it is a min heap, you can do opposite of whatever is required. Not opposite in the sense, whenever we say greater than, you have to consider it as less than. So max heap property says parent should always be larger than its children. So this is what we have to consider. In min heap, the condition is that parent should be lesser than children. So in all our lectures, we'll be considering max heap only, as we already said. So let us see what are to be done in these two cases. So the first case, in the first case, you increase the value of this node, which means you are sure that whatever is the subtree, that is surely following the heap property even after you modify it. Why is it? Because heap property says that the parent should be having a value larger than its children. And even before you modified, parent was already larger than the children. So after your modification is that you increase the value even further, which means parent is still surely larger than the children because it was already larger and you even increase the value. So this subtree, it's already following heap property. So this means because of this node, if there is any violation to the heap property, that violation should be in the path from this node till the root. So in this case, we are having only one edge till the root. But if you are having lot of edges to reach the root, then in that complete path, at any point, you can have a violation of heap property. So in that case, you want to do a heapify up operation in case you are increasing the value. What is the heapify up operation? Heapify up operation is that if you have to change on this node, after modification, you will first identify its parent and then you will check whether the value of parent is larger or the value of this node is larger. In case parent is larger, it's all well and good. You can stop there. If it is not, if the newly added changed node, if that is larger, then you have to swap parent with this node. You have to swap both these. Again, with the parent position, you again have to continue this till you reach that root. Here it is already root, so you can stop. Otherwise you have to propagate this same procedure till you reach the root. Then you can say, okay, it is again a heap. So this is in case you increase the value. In case you decrease the value, then in that case, you know that this won't cause any problem in the path to the root because whatever are up the order than this, they are supposed to be larger than this. What did you do? You decrease the value. So there should be no problem in the path to the root. But there can be a problem in this subtree because you decrease the value. Because max heap says value of parent should always be larger. And you decrease the value of parent. So there is a chance that maybe some of the children of this parent, any of the child of this parent, may be larger than the parent now because you decrease the value of parent. So what you have to do? You have to do heapify operation, also called as heapify down. So you have to do heapify operation, which will, what will it do? It will first check this parent with both the children. So when you were doing heapify up, you only had to check with parent. So there were only two nodes involved in each comparison. In case of heapify down, you have to check the parent with both its children. So three nodes are involved. then you have to check which among these three is having a larger value. If parent is having larger value, you are well and good. You can stop the. In case any of the children are having a larger value than the parent, then you have to swap that child with the parent. And then you have to again continue the same max heapify procedure with the new swapped child. Okay. So this you have to propagate till either you reach the leaf node or you reach any node at which parent is larger than its children. So then you can stop the. So this is the procedure that you have to follow. So let us just understand this first with the same tree that we used. So one value is 80. Then you had values of 74 and you had 50, I guess. Then you had 63, or you had 32 here, I think. 63. Then we had 50. Then we had 15 and 21. This is the one we had. Let us say we are increasing the value 63. So the 63 value, we are changing it to, let us say, 90. I made it 90. So when I'm increasing the value, what did I say? What is the procedure? You should go upwards. So if I'm going upwards, what happens? I have to heapify up. I'll check 90 with 74, which is larger. 90 is larger. So I'll put 74 here, 90 here. Again, I'll check 90 with 80, which is larger. 90 is larger. So 80 will come here, 90 will come here. So this is how I heapify up. So now this is a heap. Whenever I reach root, it is a heap. I'm reversing it back, 74 here. This time what I'm doing is, I will decrease the value. So maybe I'll decrease the value of 80. I'll decrease this to, let us say, 24. I decreased 80 to 24. What I have to do? I have to heapify down. How do I heapify down? I'll check the value 24 with both its children, 74 and 32. Which is larger? 74 is larger. So I'll substitute 24 here, 74 here. The next thing, I have to check 24 with both its children, 63 and 50. What happened? 63 is larger this time. So I have to swap 24 with 63. So 63 will come here, 24 will come here. And this is my heap. This is now satisfying heap properties. So this is the procedure to be followed. Let us just see what is the algorithm. So algorithm, I'm just writing this down. First thing is you have to locate. You have to locate whichever is the node you have to modify, and you can modify the value. Locate and modify. So after you modify, what is the next thing? Next thing is where you have to check whether you increase the value or decrease the value. So if you increase the value, in that case, what do you have to do? You have to do a heapify up operation. That is, you have to propagate up the tree because you increase the value. And what if you decrease the value? If you decrease the value, then you have to do a heapify down. That is, you have to propagate down the tree. This is the only difference. So if this is a min heap and not a max heap, what is the only change? Here you have to do a heapify down. Here you have to do a heapify up. That is what you have to change in case of min heap. So what is the time complexity and space complexity here? If you see locating, modification, let us say you directly know the location. You are given the location of the node, then you can directly modify. So this should be order of 1 if you are given the position location to be modified. Then what is the next step? Next step is you either have to do heapify up or you have to do heapify down. In case of heapify up, you are traveling from this node till the root. So it should be, number of steps will be depending on the height of the tree, because maximum you have to travel from leaf to the root. So according to the height of the tree. What is the height of the tree? Height of a heap is log n. So order of log n. What about heapify down operation? Heapify down operation, maximum, in the worst case, you may have to start at the root and come till the leaf. So again, it is depending on the height of the tree. It is order of log n, because height of a heap is maximum order of log n. Maximum height of a heap is order of log n. So this is the time complexity. What about the space complexity? Space complexity, if you are using recursive algorithm, space complexity will be order of log n, because in worst case you may have to use recursion stack of the size of the tree. The size means height of the tree. Recursion stack. In case you are using iterative algorithm, space complexity will be order of 1, because you don't have to use any recursion stack. You can directly solve it. So time complexity is order of log n, space complexity is order of 1 considering iteration.